Hello, this is Ms. Cliffner with your video lesson for today. How can we use quartiles to represent data graphically? Haven't given homework in a while, but I did assign BIM homework today. There are 8 problems. Let's go ahead and get started with a warm-up. You may remember this data set before. It was in a lesson where I talked about the weight of spider monkeys. And so we're going to look at this data set again, and I'm asking you if you remember how to find the median and the IQR. And remember, IQR is the Q3 minus the Q1. So first thing you do is go ahead and put the numbers in order from least to greatest. Just going to delete that, and then pause the video and try this one. I'm going to use a highlighter and cross off from the left to the right until I work my way to the middle. Go this and this. Now I have 4 numbers in the middle. I'm going to go left and right. And remember that if there's 2 numbers in the middle, you find the middle of those 2 numbers. Well, there's nothing in between 30 and 30. Plus, if I add 30 plus 30 and I divide by 2, it's 60 divided by 2, which just equals 30. The Q2, the median, is 30. Now here's the tricky part, and this is what a lot of people forget to do. I'm just going to go ahead and highlight the 30 and the 30, and I'm crossing those off. There are an even number of numbers in my data set. So the 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. The middle of the data was right in between the 2 30s, but the 30 on the left and the 30 on the right, I have to use those in my data set to find the middle of the lower half and the middle of the upper half, right? So Q3 is the middle of the upper, Q1 is the middle of the lower. So I'm going to go ahead and do the upper half first. I'm going to cross in the other direction, cross off the 30, the 38. And now I get to 2 numbers in the middle, and what's right in between 33 and 35? It's 34. So my Q3 is 34. And then I'm going to do the same thing with the lower half. I'm going to cross off the 14, the 30, 15, 27. What's right in between 20 and 26? If you add them together and divide by 2, or if you can picture it on a number line, it's 23. So the IQR is the range of the middle half of the data. It's 34 minus 23. It equals 11. That's how you find the IQR. Okay, so now here's today's lesson. And we already did some of this vocabulary in a previous lesson, but I think it's a good idea to review it again. So a lot of times we just call it a box plot. So a box plot represents the data set. It uses the least, right? I called it the min, but now I'm going to call it the least and the greatest. The 2 outside dots are the least and the greatest in the data set. This is the Q1. This is Q2, or the median. And the top fourth is called Q3. So notice that it breaks up the data into 1/4, 1/4, 1/4, and 1/4. So now we're looking at chunks of data. But notice that this part of the box here, from the Q1, oops, I want to get a different color, from Q1 to the median, notice how spread apart that is. That's what the box plot shows us. That means these numbers are not very close to each other, but then this fourth of the data, those are really close to each other. Okay, so the 5 numbers that make up a box and whisker plot are also called the 5-number summary of the data set. Didn't give a lot of room to write that. Sorry, the writing is a little messy. Okay, so now let's move on to, this is what we did. We made a box and whiskers plot. So, oh, sorry, this was the ages of the spider monkeys, not the weight. That would be pretty heavy monkeys. So if I go over here, I'm going to go back to the warm-up. You can see that this is the same data set, right? And so I have my median, my Q3, and my Q1 already done. So my median was 30, my Q3 was 34, and this one was 23. And now with my data in order from least to greatest, the minimum and maximum, or the least and the greatest, are right there. And here's what we do. We put a dot on those 5 numbers. We have a number line that goes from 14 all the way to 38. That's what I needed. That's why I made the number line that way. 23 is right in between 22 and 24. There's 30, there's 34, and there's 38. Remember that I attached the outside, the 2 points on the outside are the whiskers, the box. I do 1, 2, 3 vertical lines. That's the box in the middle. That's how you make a box and whiskers plot. You always need these 5 numbers in order to make a box plot. Okay, so now today's lesson isn't as much about making the box plot as it is about interpreting it. So hopefully this was just review for you. But practicing making a box plot is a good idea too. Okay, so here's things to remember or think about. Each section of a box plot represents 1/4 of the data. A long box or whisker indicates the data are more spread out. If you can draw a line through the median, right, the very middle point in the box, and it's not always in the middle of the box. And if each side is a mirror image, then the distribution is symmetric. And that's important because the measures of center that we use, the mean, the median, and the mode, those are going to be affected, and whether your data is symmetric or skewed will change which measure of center you're going to use. Okay, so here we go. We're going to analyze this box plot. So this shows the BMI of a 6th grade class, and BMI is this calculation that they do to figure out if you're physically fit. What fraction of the students have a BMI of at least 22? So remember, at least 22 means it starts with 22 and it includes all of the numbers in this direction. It could be bigger than that. So notice it's just this one whisker that includes all of the numbers from 22 up to 28. And this is 1/4 of the data set because each of these little sections stands for 1/4 of the data set. So the fraction is 1/4. Are the data more spread out below the first quartile or above the third? So here is the first quartile, right? This is Q1 is right here and Q3 is right here. So which one's more spread out? This part of the whisker or this part of the whisker? Well, definitely the one above the third quartile because the whisker is longer. So I'm going to say above third, I'll just put Q3. So above Q3. Now, find and interpret the IQR of the data. This is where I gave you that language that said the middle half of the data varies no more than. So I put the middle half of the data varies, or you could say varies by instead of no more than. Varies by, okay, what's the difference between Q1 and Q3? So now I look at the numbers, 20, that's Q3. It is 22 and 19, right? So this was, and I'm going to subtract 22 minus 19. So 22 minus 19 equals 3. So the middle half of the data varies by 3. And then the units are BMI. Whatever the units are, it's good to write those. Okay, there's one example of analyzing. Now, when you look at box and whisker plots, I want you to know that the name of the skew is named after the tail. So this is called skew left because the left side is the one that's longer. This is the tail side. This is skew right because it's named after the tail that is on the right-hand side. Most of the data is bunched up on the left. This one has most of the data bunched up on the right, and then they're symmetric. Now, not every graph that you see is going to perfectly match one of these, but again, the symmetric is if you draw a line down the center and it looks like a mirror image, it's symmetric. Okay, that's our key idea. So now we're comparing this box plot. It shows the prices of snowboards at 2 stores. There's store A and B. I first want to identify the shape. So I look at store A and I go, oh, if I draw a line around the center, it looks like a mirror image. So for store A, the prices in this box plot are symmetric. Store B, the tail is over here on the right. The tail is on the right, so it's called skew right. The data is on the left. Then which store prices are more spread out? Well, you can see that store B spans, if I look at the range, $2.50, $6.50, right? So the range for store B is very large, right? It's $400. That's the difference. For store A, it's only $300. So I can compare a few things, and one of them is the range. I can also say that store B has a longer box and whisker, so that's more spread out. So let's say store B has a bigger range and whisker is spread out. So that's how I know that store B's prices are more spread out. Okay, so now I just have an OYO where you're going to try to compare two box and whiskers, pause the video, try it on your own, try to identify the shape of the distribution, and then which reptiles' lifespans are more spread out. So it's comparing the lifespans of crocodiles and alligators. All right, so if I draw a line down the center of the alligator, that is symmetric. It's the shape. It's a mirror image. And then for the crocodile, this is the tail, right? This is the part that's more spread out. So this is called skewed left. And which reptile's lifespans are more spread out? I'm going to say it's the crocodile. And the explanation I give is I can talk about the range is bigger, right? The alligator is 60 minus 40, so the range is only 20. The crocodile is 80 minus 45, which is 35, right? So more spread out. Crocodile is more spread out because range is greater or bigger. The range is bigger. And let's see, I could say the below median is more spread out. Right, because both the box is spread out. Here's the median, so all of the data values below the median are pretty spread out. Okay, that's it for today's lesson.